Everyone, my name is Joel Lasco, and today we will be exploring conversational AI and AI governance in Vectorshift. Now, for better or worse, artificial intelligence is here, and it's here to stay. In just a few years since the most basic forms of ChatGPT, we've seen an explosion in AI capability, with modern systems rivaling or even exceeding human ability. Image generation models like Crayon can crank out high-quality artwork in seconds, while video generation systems can build hyper-realistic videos at the fraction of the cost of human labor. As impressive as these systems are, though, there's a growing risk of IP theft, abuse, and potential for misinformation at lightning speeds. To compound these issues even further, we see companies aggressively adopting AI tools without fully understanding the limitations and dangers of these models. McDonald's alone has invested considerable sums of money into AI drive-thru assistants, only to abandon their push in 2024 after social media posts went viral of AI consistently getting orders wrong. They've begun restarting this endeavor, but it remains to be seen if this new attempt will yield any better results. And as humorous as some fumbles might be, they demonstrate the instability of the technology. And such instability can have far darker consequences, as in 2024, when multiple lawsuits were filed claiming conversational AI encouraged children to harm themselves, commit sexual acts, and even commit suicide. This potential for harm raises serious concerns, as some companies have begun offering AI therapy, with chatbots going so far as to claim that they are real, licensed therapists who their patients can confide in. Tech leaders often romanticize this period of time as the Wild West of AI, where things are unpredictable, exciting, and full of opportunity. But in reality, it resembles something closer to the Industrial Revolution, profit-driven, exploitative, and largely indifferent to human well-being. Without guardrails, we risk repeating history. And that's why AI governance isn't just a regulatory checkbox anymore. It's, in many ways, a moral imperative. Now, for those who aren't familiar, AI governance is a general term for a system of standards, guardrails, and pre-made frameworks that build AI systems that are safe for users and the public. You might have heard it referred to as ethical AI. It's kind of the same thing. AI governance can involve legal mandates to ensure safety, outside auditing to ensure systems are working properly, and developmental guidelines that focus on how the AI actually works and gets built. Now, since most of us here are involved in development, we'll be focusing on this central phase. If we want to actually adhere to ethical development practices, we can refer to the Artificial Intelligence Risk Management Framework, which was developed by the U.S. Department of Commerce in 2023. According to this framework, an AI must impose minimal risks to users and the public while producing reliable, consistent results. We also need to protect user privacy, ensure system security, and ensure our AI responds appropriately in usage scenarios. And lastly, we need to be able to understand how and why a model gives its outputs. Now, this sounds like a lot to do on top of already developing an AI system, but with the proper development platforms, we can keep track of everything with minimal issues. One such tool for this is a platform called Vectorshift. This is an open source AI development platform with tools both for coders and non-coders. It can be used to bridge AI systems with other platforms like Google, Salesforce, and other cloud services. And it can do much more than that too. And most importantly, the platform is PPI and HIPAA compliant, meaning it can safely handle sensitive user information, making it ideal for services in the medical industry, or those just wanting to ensure any user information is handled safely and discreetly. Vectorshift gives us access to integrated pipelines where we can build our models piece by piece. And as a visual person, this is also a fantastic tool for blueprinting or just brainstorming potential models. We have access to dozens of LLM providers and can even access our own LLMs if we have them available. We have access to multimedia tools, which dramatically boosts our model's potential. And Vectorshift uses end-to-end encryption and guardrails to hide personal information. On top of this, all user information is deleted after instances close, meaning once a user closes the application, they don't have to worry about any data leaks on Vectorshift's end. So how about we try implementing everything that we've learned about Vectorshift and ethical AI to actually build a chatbot? If you've ever had a panic attack, it can be difficult to pull yourself out of that panic spiral. One of the techniques that we might actually use to help someone in this state is something called the 5, 4, 3, 2, 1 grounding technique. This is a mindfulness strategy that works to bring patients back to the present by helping them focus on things in their environment, and has actually proven to be extremely useful for those coping with PTSD or extreme anxiety. And it's not without its difficulties, though. When you actually have a panic attack, it's common for people to experience a form of tunnel vision as your body enters fight or flight. When you're in this state, memory recall plummets. You're basically frozen, and the ability to think of anything other than the doom going through your head basically goes out the window. Kind of hard to practice the 5, 4, 3, 2, 1 technique if you can't even remember the steps. So those suffering from panic attacks could also feel a sense of isolation, which compounds the fear. You're alone and you're having a panic attack. You don't have anyone to talk to. And when you're alone, trying to pull yourself out of that hole is not an easy task. It's difficult to do even at the best of times, because to be honest, in the modern technological landscape, mindful awareness is hard. A lot of us have become attuned to plugging in and shutting off, so we actually start to struggle with registering our surroundings. Just try it. See how long you can go and how present you can be without your phone. And worst of all, just knowing the steps isn't enough. It takes trial and error to work through these mindfulness steps and actually stay present and calm yourself down. Therapy is a great place to practice these strategies, but we don't always have access to a therapist or have one on standby if we're breaking down mentally. And that's if we can even afford a therapist. So what if we had a tool that we could speak with that walked us through the steps? What if we could have a conversation with it to soften that sense of isolation and remember that we should be doing what we should be doing to pull ourselves out of that fight or flight state? We could actually do that by building an ethical AI chatbot. It wouldn't be a replacement for therapy, but it could help patients practice a skill that they could rely on day to day. So if we built an ethical AI to accomplish this, what would that require? Of course, it would have to be HIPAA compliant because we're potentially handling medical information. As a user talks to this bot, they might be mentioning sensitive material. We want it to feel like you're speaking to a human, but we only want it to ask relevant questions during the conversation to keep the user in that grounding session. It would need a minimum output because we don't want to detract from the person's struggle. We don't want to make this about the chatbot, and we want to keep the focus on the patient. We would also need short-term memory so the bot could actually remember what's being said during the conversation and where to progress the patient next. We would also want to make sure absolutely that it only provides safe responses, meaning no unrelated thoughts or ideas and no toxic behaviors. It's here strictly to guide users through a safe grounding session and nothing more. But let's try and build it, and let's build it in Vectorshift. So if we're ready to actually start designing our model, we can head to the pipeline section of Vectorshift. Here we're going to have access to a workflow. When we open it, we're going to be able to construct our model. We won't actually go through and construct a model piece by piece, but I'll walk you through the one that I have right now. Here we have a input node, which is what defines the type of material the AI is capable of processing. Here it's going to be text because we want to make a chatbot. The text gets fed into our knowledge base to provide some context to any of the questions that we ask, and then the knowledge base information and our text is fed into a new text node. This reformats our input in the context of that knowledge base and then feeds that into our perplexity model. We chose perplexity because we saw that Llama produced the most reliable results and also had a pretty good runtime and it's cheap, but it's up to you. So then we specify our instructions. We define the role of the model, how it should respond in the case of suicidal ideation. And we also specify how it should give its responses and also that it must provide a reasoning for any response. This is actually pretty useful because this defines how we can troubleshoot any information. We can also go to our settings and change the temperature, or we can also come down here and filter for any personally identifiable information. We don't want to filter for toxic input though, because in a grounding session, we don't want a person might be going through some stress or be processing something particular that a toxic filter might otherwise prevent the model from interpreting. So while not inputting a toxic filter might actually boost the likelihood of giving us inappropriate or unprofessional responses, we are hopeful that our instructions themselves will be enough to provide those guardrails. So then what we can do is we can feed our output into a data parser, and this is going to isolate our final answer and our reasoning. And then we're going to feed our reasoning into this output node over here. Down here, we have chat memory, and we also have that being fed in with the reasoning of any responses we give. So what this is actually doing is this is going to build a chat log for us that we can refer to later on if we want to see how the conversation went or what went wrong or what the model's reasoning was. So then what we can do once we want to see how our model actually works is we can hit run and go to the chatbot feature. We want to specifically use chatbot, otherwise we aren't going to have access to memory. So let's start with I'm having a panic attack. And let's see what happens. So right away, we're getting the first step of the 5, 4, 3, 2, 1 method, and it's telling us to start looking around the room and gives us an example of how we should be reporting our findings and then why we care about this. If we go down here, we can actually see a full output of the conversation with reasoning and the final answer. So next what we can do is, if we're confident that our model is working reasonably well, we can now start doing some stress testing. So this is where we're going to give a bunch of different inputs to our model and see how it responds. So we can go to bulk jobs here, and we can enter this environment. And here we have an input display. So we have the option to also upload some data. Now, when we upload this data, we're uploading a bunch of different inputs that range from toxic to friendly to emotional to baiting questions that are trying to actually repurpose the instructions of the model and trick it into doing something it shouldn't be doing. So what we can end up doing is running a bulk job, and it's going to give us a whole list of outputs for every one of these inputs that we give. And so input 0, remember that is what the user is going to be seeing. And we aren't going to actually run this because it's going to take forever, but what we end up getting is something like this. So here I've also added the sentiment for each of our inputs so we can track how it performs with different sentiments in mind. And so now we have a saved CSV file of all of our model's responses over 93 different inputs. Now, once we've created our CSV file from our bulk job step, we can take that information into Colab, where we can call different models to actually evaluate those responses. So here we're using different LLM models from Google, Cohere, and we're also using Anthropic. So what we're doing, this is basically what the data structure is looking like. We have our input, we have the sentiment of that input, and then we have the model's output. So we are going to be going through and we're going to evaluate all of these outputs in real time, and we're going to determine if they're inappropriate or not. And you can see that Gemini is actually labeling a lot of stuff as inappropriate, so that's a sign that we might want to check it later on. But the benefit of using 3 different models is that if one model provides any bias towards the evaluation process, you can get a more well-rounded evaluation. So we have Cohere. Here we're using, it looks like Command R, so we're getting 93 outputs or 93 evaluations. And so in all of these, we're looking at both professionalism and appropriateness. So we've defined that for each of these models, they have to evaluate if the response is appropriate for a 5, 4, 3, 2, 1 grounding session, and if it's managing stress or anxiety. If it does, then return appropriate. And then also we have to classify if the model is giving a professional answer or a toxic answer, something that sounds like it's hurtful, or if it sounds like something that is actually professional. So by the end, and we're not going to go through this in real time because the code is going to take forever to run, we are going to get a final output with every single one of our inputs and outputs evaluated by these LLM models. So what we've done is we've pulled in 3 LLM models independent of the one we used in Vectorshift to evaluate Vectorshift's outputs. So once we have all of those, then we can start doing just some basic algebra and math to really evaluate overall how these models are, or how our model is performing. So we can see that using a majority vote ruling, that everything is voted as professional by the majority of the models. See that Gemini does get pretty strict, especially it looks like with emotional inputs, it tends to grade pretty harshly. But this is, again, one of the benefits of majority rule, because then if one model is biased, then, or providing very, very low answers, then it's helpful to look at another model to see if things change. So then we can start looking at majority rule of sentiment specifically, and then we can start to look at the overall scores that were given by Gemini, Cohere, Claude, and the majority across all different sentiment types. So we can see that majority of the time we're getting 100% of our models being appropriate, or 100% of our outputs being appropriate. Then we can look at sentiment, And here we see sentiment drops a little bit, so there is room for improvement with our model. You can see that Gemini and Claude both are pretty harsh. Cohere is far more favorable, but considering we have Gemini and Claude both giving some penalties, it might be good for us to actually go back and check what some of our outputs are and see if there are any improvements we can make to the model. We won't do that at this stage just because of time, but that is something we will be focusing on later on. All right, so let's say we've gone through the pipeline phase, we've ensured that the model can work, we've gone through the stress testing phase, now we want to actually deploy our model. So what we can do is we can head over to our chatbot feature in Vectorshift, and there we're going to have an option to deploy a chatbot. So here I have Avery, which is a basic chatbot that users can use. We can customize it a little bit to give it some color, add in a couple profile pictures, and then a couple disclaimers that this thing is not being used for therapy. We can also add a welcome message and also have Avery text first. That way it gives it more of a personable feeling. These are all things that you can customize over here in your customization window. Once you're ready to actually export, we can hit export, and then we're going to get a URL. So we can hit open chatbot. Now, once we're here, we see a welcome message, and we can start talking. Let's leave in the errors, just so we can still see if Avery can pick that up. All right, so we're actually getting a good response here. We're getting the first step of the 5-4-3-2-1 grounding technique. We're getting an explanation of what to do. We're getting an example, and we're getting told how this is actually helping us to stay grounded. So this, from here, we can have a conversation and try to actually ground ourselves if we're going through a panic attack. Now, you might notice over here that we have a bunch of old conversations. These are all from me kind of testing out this model. So unfortunately, there is a bug in Vectorshift right now where if we try to delete these conversations, we get warnings that we will never be able to see them again. But when we actually refresh the page, we're going to see them come back. And there they all are again. So this is unfortunately a pretty annoying bug that hopefully Vectorshift can get plotted or get sorted out soon. If not, then we can start to move on to other platforms. At least at this point, we now know the grunt work. But at this point, we have successfully deployed a chatbot assistant, and we'll now start to evaluate how well we've done and if we've satisfied the ethical AI framework. And now we're done. Let's check if our model actually satisfies the AI RMF 1 framework. We installed numerous guardrails and instructions that limit the output of our model, along with adding responses in the case that we suspect our users intend harm to themselves or others. So we can argue that, yes, we do have a safe model. We processed 93 different inputs of varying sincerity and toxicity using 3 independent models, and we found that the assistant consistently provided appropriate and professional responses, so we can say that it is reliable. We filtered for protected personal information, used a HIPAA-certified platform to run the model, and have all user information deleted once they stop using the program. So we can say we've taken reasonable steps to ensure user privacy. Granted, there is currently a bug in the Vectorshift platform that brings back old conversations, but hopefully this gets resolved soon. If not, we know the grunt work necessary to build a proper ethical system, and we can do this again in another platform, like Vappy, which also provides HIPAA precautions. On top of this, we've also ensured that any responses are explainable, and we've also been using this entirely on an end-to-end encrypted server, so we can argue that our system is both secure and reliable. So let's summarize everything that we've gone over, because it has been a lot. We discussed the different aspects of AI governance and how they help us make safe, ethical AI models. We explored Vectorshift, an AI development tool that's optimized for AI governance at the developmental phase. It gave us a litany of tools for the developmental phase, and it provided HIPAA-compliant security measures to protect any data from our users. And then we used Vectorshift and what we know about ethical AI frameworks to build a panic attack assistant that satisfied HIPAA and AI RMF standards so that our users could go through the 5-4-3-2-1 grounding technique. And we did this all at a low cost while also making sure we generated safe and appropriate responses. Granted, there are still additional steps we could take to improve our model, like more robust stress testing at different scales. trying different LLMs to see how processing times might differ, and finding methods to build more human outputs without compromising safety. And if we want to get really nuanced, we could actually look into SMS chat features. This way we could have users text to the model as opposed to having to log on to their computers to contact this AI when they need support. But those are all projects for another time. If you have any insights or you have any questions about these tools, feel free to reach out on LinkedIn or GitHub. Or if you want to talk more about Vectorshift, I'd be happy to help out with those. Hopefully this has inspired you to build some more ethical AI systems or to play around with some of the tools that we discussed today. But in the meantime, I hope you have a fantastic day. Thank you.